Hi, welcome to Bits and Proofs. Today's a foundations lesson, agent to agent and the infrastructure around it. We will go over an agent to agent protocol request from one agent to another and scenarios from start to finish. Picture two agents. You build a trip planner agent. It is good at planning a journey. Another team builds a flight agent. It is good at finding suitable flights for my travel. But they run on different systems using different tools. Right now, they cannot work together. The protocol that lets them cooperate is called A2A, which is short for agent to agent. So let us define A2A clearly. It is an open standard that lets agents built by different teams discover each other and work together. It is an open standard looked after by the Linux Foundation with many companies taking part. It is framework neutral. The two agents need not share a language, a vendor, or a code base. And it uses plain web technology. It runs over secure HTTPS using JSON messages. Let us name our two agents. On the left, the trip planner. It is the client, the one that asks for work. On the right, the flight agent. It is the remote agent, the one that does the work. The link between them is A2A. We will now follow one request as it travels across that link from start to finish. The first piece of A2A is the agent card. Every AI agent that implements the A2A protocol publishes a small file that says who it is and what it can do. It lives at a well-known address on the agent's own domain. Look at what is inside. A name, Flight Finder. A short description. A web address to reach it. A version and a list of skills. Here it is just one, search flights. A name, a description, an address, and a list of skills. That is all it takes for an agent to introduce itself. Step 1 is discovery. The trip planner fetches the flight agent's card from that well-known address. In a single read, it now knows three things. First, what the agent can do. In our case, search for flights. Second, where to reach it. The service address from the card. Third, how to sign in. The credentials the card says it expects. It is just like reading a business card before you make the call. Step 2, the planner sends a task. A task is the unit of work in A2A. It carries the request as a plain message. Here is that message. Find flights from Delhi to Singapore on the 12th of March. Notice it is just ordinary text. Two small but important details. Every task gets an ID, so both sides can refer to the same piece of work. And the message is plain text. The planner does not need to know how flights are actually found. A task does not finish in a single step. It moves through clear states. It starts as submitted. Then, working, it may pass through input required. And finally, completed. While it works, the flight agent streams progress back, so the planner is never left waiting without an update. Input required means the agent needs a little more from you. For example, would you like a morning or an evening flight? A task can also end as failed or as cancelled. Whatever happens, the state is always clear to both sides. Step 3, the result comes back. When the task is completed, the flight agent returns an artifact. That is the finished output. Here it is. A status of completed and an artifact holding the flights it found. One option from Indigo, 11,200 rupees, non-stop. The planner now holds flight options it never had to fetch itself. It simply asked a specialist and trusted it to deliver. A real trip is more than flights. So the trip planner does the very same thing with a car rental agent and a hotel booking agent. One planner, many specialists, all working in parallel. And the protocol is identical every time. Each specialist publishes its own card, accepts a task, and returns an artifact. Learn the loop once, and it works with every new agent you add. Each specialist is an independent agent owned by a different provider and discovered through its own public card. That is the real power of A2A. One planner, many specialists. But do those specialists run at the same time or one after another? It depends on whether the next agent needs the result of the previous one. Take finding flights, a car, and a hotel. None of them need each other's result. The planner can send all three tasks together. They run in parallel. The total wait is only as long as the slowest one. Now take booking and payment. Payment needs a confirmed booking ID before it can start. So the planner books first, waits for the ID, then sends the payment task. That is serial, one step after another. A real trip uses both. Search in parallel. Once the user picks their option, book and pay in sequence, the planner decides the order based on what each agent actually needs. Now, the infrastructure behind A2A. First, every agent is simply a web service. It lives behind an HTTPS address, and you reach it like any web API. The transport is light. Calls travel as JSON messages over HTTPS, a format called JSON-RPC. And for long jobs, the agent streams its progress live as it happens using server-sent events. One service can host many agents at once. This is called multi-tenancy. So a single provider can serve a different agent to each of its customers. And agents are found by address. Each one has a well-known web address, and shared directories help you discover many agents at scale. When should you actually use A2A? Use it when the work belongs to a different team's agent that you do not control. Use it when you want specialist agents that each own one domain and improve on their own. Use it when the other agent should stay a black box, where you only see its card and its results. But not for everything. If it is just a simple function call, you do not need A2A. Use A2A when the other side is a whole agent. Now, a short note on trust and safety. The current version lets an agent sign its card, so you can confirm the card truly came from that domain and not from an imposter. Authentication is declared in advance. The card states what credentials it needs, so access stays under your control. Treat results as untrusted input. Another agent's output is data, not a command. Check it before you act on it. And share the least you need. Send only the information the task requires and nothing more. Let us put it all together. Remember three things. 1. A2A lets agents from different teams discover each other and pass work to each other. 2. Three pieces carry every exchange. The agent card, which says who you are, the task, which is the work, and the artifact, which is the result. 3. It is an open standard, so any two agents that speak it can work together, whatever built them. So where does this go next? Once agents can talk, the next question is how to coordinate many of them on a larger job. Who leads, who follows, and how their results are combined. That is the world of multi-agent systems, which we explore in the related lessons on this channel. Thanks for watching. If this helped, do subscribe. More AI engineering content is coming soon. And while you are here, check out the other AI engineering videos already on the channel. See you in the next one.